Hello, everyone. Yes, my name's KJ, and as you introduced me, I'm an engineer at Zendesk and a committer on the Ruby core team. And I'm talking about our fun adventures scaling our Redis writes open with cluster mode. I didn't have time to rename the talk to like Valkey or what was the other one? Redict. So it's just Redis here. Also, please feel free to throw something at me or shout out if you want to interrupt me and tell me that something didn't make sense, because I'm good at not making sense. So, all right. I should also talk about what we do at Zendesk for those that don't know. We're kind of a customer service software platform, so we deal with everything from email-based ticketing workflows through to kind of advanced AI chat features and all that good stuff. All right. So, what is our story about today? That is a photo of our office in San Francisco, and this is relevant to this talk. I work on a team that's kind of responsible for the overall health and reliability and well-being of our big million-line monolith application. We're a distributed team, so I've got a few people in Australia. We've also got many people kind of spread far and wide throughout the United States. And so we normally kind of do all the remote work things. But we got the opportunity last year to come together there at our office in San Francisco, have a bit of a team offsite. This is great. I think we went bowling and had some food and all the fun things. And we also got a lot of really good work things done, like setting some vision for the future and a bit of pair programming, all the good things. There was, however, one thing we got to do together in San Francisco that I was not expecting to do, and that is in-person incident response, like the good old days where you've got the war room and you're all together trying to fix the incident. So our incident that happened around that table was related to this guy, one of our many Redis instances, affectionately known as MISC, which kind of probably gives you the idea of what goes in there. I need to thank my colleagues and Prakriti for telling me I needed more memes in my talk, so I made some big adjustments. Basically, the problem with MISC was that something had happened, it was using too much CPU, the alarm goes off, we get paged, we look at it, kind of looked at why is it kind of doing that, and it was pretty much usage related. And this cluster, or this Redis instance, was actually Elasticache cluster mode enabled Redis. But it only had one shard, so it's not really much of a cluster with one thing in it. So we kind of saw that, and we're like, well, great. Just get out our checkbook to Mr. Bezos, click the button in there, and said we wanted more shards, and wrote Bezos a nice check. And it didn't actually fix everything. In fact, it made everything much worse. So the original problem was kind of not that bad, and not really the world is on fire problem. But when we scaled the Redis cluster out, we started seeing this kind of thing. These were weird and wonderful errors that we'd never seen before. Things like cross-slot pipelining error, or move 3016 in this picture. These were very serious. They were causing real problems, and we had no idea why they were happening. So we kind of undid the scaling and went back to our one-node cluster. But there we are. We're kind of finished that, and we're like, well, why did that go so wrong? So we had to spend a bit of time learning how to Redis and learning what this cluster mode thing was and why did it not work so good for us. So I'm going to kind of give you the speed run of the different ways to deploy Redis, which we learned about as part of this fun learning exercise. So this is the easiest Redis. Thanks, Stephen. But if you want something that's more Redis than that, you could have one server with Redis on it. So you I don't know, choose your server provider of choice and apt install Redis, and there you are. You have Redis. And this is good. It's simple and cheap. And if this is good, you can just leave, and you can get 30 minutes of your life back, because this isn't that interesting otherwise. But unfortunately, sometimes we need things. We need more than this can provide. Sometimes we need high availability. We need to make it so that if our one Redis server goes down, we still have a Redis. Sometimes there's a data loss issue here. Sometimes we need replication. We need to make it so that if our Redis server goes down, we don't just lose whatever data it was holding. And relevantly for this talk, scaling. You get as much Redis as you can get out of one server when you do this. And if you need more than that, we'll need a different approach. All right, so the original kind of high availability approach, I don't know if it was actually the original one, but one of the early ones is Redis Sentinel. So Sentinel is actually distributed as part of Redis, but it's actually a separate process that runs next to your Redis process. So you might have some servers with Redis. You can also install Sentinel on them. And the Sentinels will get together, have a little election, and decide, all right, one of us is going to be the master, some of us are going to be the replicas. And then Sentinel kind of configures Redis to say, all right, you're the master, or you need to replicate from that Redis. That means there's application support required, right? Your application doesn't know which of these three Redeye is the master node, so it has to ask Sentinel, and Sentinel will say, OK, right now it's node number 1, so connect to that one. And if you use the Redis gem, that's handled for you. You provide it the address of the Sentinels, and it'll do that little dance for you. And there you go. You get to connect to the current primary. So this is good. We don't have a single point of failure anymore. One of those Redis nodes goes down. Sentinel will promote one of the replicas to be the new master. And then your application finds out about that because it understands Sentinel. You can also use this approach to scale reads out. So if you have a very read-heavy workload where you don't do a lot of writes, and you can tolerate slightly stale data, your application can opt into reading from those replica nodes. So you can distribute the reads amongst all three of the things in that picture. Unfortunately, this doesn't work for writes. Under Sentinel, every write must still go through the one Redis instance. So it doesn't help with our problem where we had a write-heavy workload. So there's this thing in the Redis gem called Redis distributed. And what this kind of does is got the idea that, like, all right, we'll take, we've got some Redis servers, and we'll cut the keys in half. So some keys go there, some keys go there. And it'll use like a hashing algorithm to choose which keys go where. And this is good, except if you did what it says on the picture here, we've lost our high availability. Because if one of those Redis nodes goes down, well, we're going to lose half of our keys, which I guess is better than losing all of your keys. But I'd rather not have any angry customers. So with their powers combined, we can copy-paste the Sentinel picture from the last slide into here and kind of have a distributed of Sentinels. So we have two different independent Redis Sentinel clusters, and then Redis distributed cuts the keys in half between the two of them in your application. So this is good. This gives us horizontal write scalability. Under this picture, we get twice as much Redis throughput for writes as we could if we only had one. The problem is, sorry. The problem with this is, how do you get in a situation where you're doing all right, like we were, with some number of nodes, and you realize you need more nodes? Redis distributed hasn't got a way to solve this problem, right? You've cut your key space in a certain number of ways, but then if you try to add another node, you somehow have to decide, well, which keys are we going to put in the new node, and where are they going to come from, and how are we going to copy their values over, and got to tell all the app servers at exactly the same time to start using the new server. So distributed kind of lets you start at a particular scale, but it doesn't let you change that scale at all. There's no, I guess you could say it's not scalable. Yes, I forgot to do the meme. And I think I just said that. All right, so yes, we've got read and writes, but we can't scale them out. That is the problem that Redis cluster is designed to solve. So that's where Redis cluster mode fits into the architecture of Redis. So in Redis cluster mode, we kind of carve up the key space into 16,000 slots. And like with distributed, a key slot is basically just determined by a hash, the CRC16 hash. Now, your Redis nodes will kind of get together and have an election, like with Sentinel, and they'll decide which slots are going to be served by which nodes. So at the end of this process, you should end up with a Redis cluster where every slot is served by one primary node, exactly one primary node, and one or more replica nodes. So in this picture, the first 5,000 slots are on node 1, and then so forth. And your application needs to know how to send the right keys to the right servers that are expecting them. So because of that, we need, again, client library support, right? If you've got the Redis gem, it's got this Redis clustering capability, which understands how to ask the Redis server where the slots are supposed to go. So the protocol's got like this cluster nodes command that you can kind of see it. But it returns like a list of the nodes in the cluster and which slots they're responsible for, basically. And so armed with this information, the Redis gem can know, all right, you want to write the key hello, that hashes to this slot, therefore it goes to 172.168.40.242 or whatever. We also have the ability with Redis cluster to make changes to this cluster topology. So if we add a node to a Redis cluster, the Redis clustering machinery behind the scenes will actually decide to move some slots to that cluster. It will copy the current values of the keys, and it will use like a kind of consensus algorithm to officially declare, OK, these slots now belong to this node. And the application gets made aware of this too via this thing called redirections. So if you ask a Redis cluster node for a key that it's not responsible for, like I asked this particular node foo, you get told, I don't have that, but you should ask this other guy. And then the gem kind of can remember, all right, well, all of this slot now belongs to this node. I thought it was there, but actually now it's moved to here. So this is how your application can kind of be made aware of changes to the number of nodes or like nodes coming in and out of the Redis cluster. So that's given us scalability, right? We can scale out reads and writes. If we add nodes, those nodes get more slots, and we've kind of increased the write capacity as we do that. Now, the downside of Redis cluster is that it kind of requires some quite complicated and finicky library support. That's the foreshadowing. There's a lot of tricky cases around, well, what happens if the key is in the process of being moved? What if some of the keys in the slots have been copied, but not all of them? What happens if you've got a network partition? These are not questions you must ask when you use a single Redis server, but the client library must handle all of them. All right. So hopefully we've kind of gotten through the taxonomy of Redeye and understand where Redis cluster fits into this. And I think we now have some language to go back to our original incident and work out what was going wrong. So recall, we had a Redis cluster that was one shard. So that means it looked something like this. It's multiple, it's like one set of nodes, and all of the slots are served on a single master. So for all intents and purposes, it's not really a cluster. We tried to scale out something like that by adding more nodes, which will give them their own slots. And we got these problems. So let's see if we can kind of make some sense out of these words. Start with cross-slot pipelining error. Well, we now know what a slot is. That's the value that the key hashes to with the hash function. So what does it mean to be cross-slot? So Redis has got commands that operate on multiple keys at once. If you've used Sidekick Pro, which I think got a shout out somewhere today, that makes quite extensive use of these multi-key operations to kind of give some of the durability guarantees that they promise. So this example is trying to set two keys, my key 1, my key 2. Normally that works. In Redis cluster, multi-key operations work as long as all the keys belong to the same slot. So in this example, my key 1 and my key 2 don't happen to have the same hash function, so Redis tells you off. It says, no, can't do that atomically. Basically, you can't do anything in Redis cluster atomically across more than one server. And the only way to guarantee keys are on the same server is for them to be in the same slot. So we've got a solution to this. You can use hashtags. If part of your key name contains a brace like this, Redis cluster will only hash the part inside the key to consider what slot it belongs to. So in this case, these two keys, my key 1 and my key 2, both now start with foo. And because of that, because it's in a hashtag, only foo counts towards what the slot is, so that they're in the same slot, so you can get them at the same time. All right, so that's cross-slot. Pipelining. So ordinarily, you want to ask multiple questions of Redis. You might get a key, read the response, get another key, read the response. But if you know ahead of time which keys you're going to ask for, you might as well kind of fire all the questions at the Redis cluster, at the Redis node at once, and then read all the responses back. There's no point waiting for the response because like you don't really need to pay that extra round trip time. So if you do something like this, it's called pipelining, and it can give you a performance increase rather, where you're making a lot of kind of requests for different keys, and you don't need to know the responses right away. OK, cross-slot pipelining. So if you ask me now to draw a picture of what cross-slot pipelining is, I would draw something like that. You've got multiple, I don't understand why this didn't work, right? Because in theory, the Redis gem understands we're doing a pipeline of 3 keys. So we know that these keys belong to this shard, these keys belong to this shard. We'll kind of split the pipeline out so that every shard gets the keys that it's responsible for, and then fan the responses back in. And I was like, well, this should work in Redis cluster. I don't know why it doesn't work. And the answer is it does work in Redis gem v5. So yeah, we had finally paid the price, it seems, of ignoring the mountains of deprecation warnings that have been printed to our terminals for the last 2 years or whatever. But seriously, so the Redis gem has got a new maintainer for the clustering support in v5, and it's this super Caracal gentleman, and he has been very assiduously improving the clustering support in the Redis gem a lot by adding things like cross-slot pipelining support, for example. And we were not getting those benefits by being on Redis gem v4. So yes, I don't think this is going to be a terribly controversial statement, but it amazes me how this never seems to bump up to the top of the pile. There's always something more important. So we'd learned that to fix those cross-slot pipelining errors, we needed to upgrade to Redis gem v5. So that was a whole other banana, which is a different talk. But we kind of did that eventually and shipped a branch to our testing environment to see, did it work? And yes, we stopped getting those cross-slot pipelining errors. But we did see a few other errors, and they were related to transactions. So let's talk about Redis transactions, and then I'll get into what was going on. Yes, let's talk about transactions. I can't see my notes. All right, so I think the best way to think of transactions in Redis is conditional execution. So I asked ChatGPT for this example. I'm like, please give me an example of transactions in Redis, and it spat this out, which I think is a good one. So let's imagine we're running a ticket master, and we've got the number of tickets remaining in Redis. So we might want to enter application, please get the number of tickets that are remaining, and if there are tickets remaining, let's decrease the number of tickets remaining and sell you the ticket. And normally, when you will successfully get the number of tickets and then decrease the number of tickets, provided it's not already 0. But sometimes someone else might have bought the last ticket kind of while you're in the process of that. And we don't want to end up with -1 tickets remaining, because then someone's going to be very upset about them not being able to see their favorite rock band or whatever. So transactions in Redis when I say they're conditional execution, it means watch this key, that's the first line, and then when we exec the transaction at the end, it only applies the update if the key's value didn't change. So in the case where nobody else had modified the number of tickets remaining in between these 2 steps, we see that exec correctly runs and reduces the number of tickets remaining. But in this case, where someone else sneakily got in with the last ticket, that precondition of tickets remaining isn't true anymore. That key changed. Therefore, the watch fails the transaction. So that's why you might want to use transactions in Redis. Now, I think I said before, you can't do anything in Redis cluster that's atomic across multiple servers. Therefore, transactions in Redis cluster should actually work if all the keys in the transaction belong to the same slot. Unfortunately, so we were looking for problems with our Redis library when we had deployed our testing branch. And we saw these kind of ambiguous node error things. But actually, we've been getting those for like ever. This is not new at all. And it turns out that basically transaction support in the Redis cluster gem was kind of only half there. I think it supported like multi-exec, but it didn't really support that watch functionality that like lets you cancel the transaction if someone else has modified it. And this is not like a knock on the gem maintainer, because this is really tricky, right? You have to think about what happens if an exception gets thrown halfway through your transaction in Ruby. You have to make sure you do it on the same connection. So this was all like a little bit tricky. And it wasn't supported in the gem yet. So we were presented with this choice. Hand on my heart, honestly, we probably could have hacked around this problem. Some of the situations where we were using transaction probably didn't need them. Some of the other ones, like we could have done something gross, like make a different Redis that's not a cluster and like do the transaction, do those operations on that Redis. But I think to the credit of our org, we were pretty determined that we were going to actually try and hit the button on the contribute upstream button. I can't see which direction it is. And this is for a few reasons. So obviously, many of us work in companies where we've gotten a lot of good out of open source. And this was our opportunity to do something good back to open source, to kind of pay back into the bank account we were kind of taking out of. So there's an altruistic reason to do this. But this makes business sense too. So when we fix problems like this in the upstream gems where the problems came from, we're more likely to land on the right solutions. We're not going to create like some silly architecture problem involving more Redis machines that exists just because there was a bug that we couldn't be bothered fixing. It's good to make your application kind of work the same way as other applications when they're not doing anything special. I got to be a little bit careful here. My boss is in the audience. But one day, I would like to be not working at Zendesk. I'm only 34, right? And when that happens, I would really like the person that has my job next to not hate me. And if what I've left them is a giant ball of hacks and KJ-isms that like doesn't make any sense and like is just the path that we happen to follow and did the easiest thing at any given time, that's bad for the continuation of the code base. Where things are standard Ruby, Rails, computer things, we should use standard Ruby, Rails, computer solutions and save the special crazy things for situations like where there's a business reason to do something special and crazy, where it gives us an advantage. And finally, working on your gems is like a good, what do you say? It's good investment in your knowledge, right? So it's good for the company to have people that understand how the next layer down works, because they will cause problems one day and they will need to be fixed, and it's good to have that expertise on hand. But it's good for you all as engineers to have some experience with something new. We're always got to be learning in this field, and anytime you get the opportunity to dive into kind of the code base of a gem you're using, that's making you a better engineer. Okay, so this is my first attempt at fixing this upstream, or my first 3 attempts at fixing this upstream. Honestly, it was not a super fruitful relationship, because I kind of sat there on my computer and like made an enormous diff that fixed the whole thing at once on my machine. And I flung it over the wall as a giant pull request, and the maintainer was like, what are we trying to achieve here? And I don't like how you did this. And then I kind of redid the whole thing in a different way because they left a comment. So now he's got to review 668 different lines. And we kind of went back and forth quite unproductively, where he'd kind of make a comment and I'd do the whole thing in a completely different way. And it was kind of very difficult for him to difficult to understand what we were trying to do, and it's very difficult to review, this much code all at once. I'm sure we're all familiar with that. And some of this is quite fundamental, right? The clustering support requires mucking around with kind of a lot of how the connection management works. It requires mucking around with like how the retries and stuff work. So, this is tricky code deep in the bowels of the code base, and I was not really engaging in a productive way. So eventually, we hit the circuit breaker on this, and I had a conversation with the maintainer on GitHub about what we were actually trying to accomplish, and we debated what the design should look like and kind of explored the design space a little bit, came to some understanding of like how this should look, and then there's a giant issue of me chipping away at this with multiple little PRs, and I think I must have sent like quite a number, like 10 at least, smaller PRs to eventually build towards that goal. And obviously small PRs is good, but I don't want the lesson here to be just make smaller PRs, because it would also be like really confusing for the maintainer if I just sent the first PR, which is like refactor how retries work. He'd be like, okay, but why? So it's important not just to give reviewable chunks of code, but also to give reviewable chunks of code that build towards some shared understanding of what we're trying to achieve. At the end of the day, I think, this slide, I forgot, yes. So you might be thinking that like, I'm not a 10xer, how could I contribute to like the Redis gem or whatever I happen to use that's important? But I thought this interaction was quite elucidating for me. I was explaining that I was testing this in our testing environment, and the maintainer was like, yes, please give this more testing. I don't actually use this in production at work, so please give it a crack and report the issues. And we've all got valuable things to contribute with our use cases, our environments. So I guess the point here is like, this is something that anyone, it's valuable to test something out in your environment and work upstream, even if you're not, super familiar with hacking on the code straight away. And in the end, I'm really happy with what we built upstream in the Redis gem. As part of the process of working out how clustering support should work in the Redis gem, I did a bit of a survey of how it works in other languages, and it was depressingly easy to do that survey. The Go one is actually pretty good. The Go cluster client was probably the best one that I found. The rest of them basically didn't support transactions at all. Except now I think the Ruby one is actually the best one, because it fixes a couple of edge cases that I noticed with the Go one because I looked at it, and we've given it a really thorough workout in our testing environment. So, by working with the open source community, we've built something good for the community, and I think ended up with a better solution than we could possibly have hoped for on our own. So yes, that's the lesson from here. Like, work with upstream, whether that's by testing pre-releases or filing issues, like filing good issues, or fixing bugs that you find, or debating how you should implement new features. Like, having a productive relationship with your upstream, going to be good for you as engineers, good for your company, and good for Ruby. Okay, now we come to the end of our story. That is the Luxor Hotel and Casino Las Vegas, which was the location of this year's team offsite. Yeah, someone must have found some budget, or really likes blackjack, I don't know. But yes, so we got together again this year, and I thought it would be kind of nice and symmetric if we deployed our change to upgrade the Redis gem, including our patches, while we were there on our team offsite. And we were going to do that, and then our group tech lead said, maybe you shouldn't make a big production change while we're all busy at the team offsite. And I was like, fine, Leonard. Way to take the fun out of it. No. He's good fun, actually. But no, we went home and did it next week. But we did it. We shipped the please upgrade to Redis v5 thing. And this includes all the patches that we've been working on with the Redis driver. And kind of shipped it. It was fine. We tested scaling that MISC cluster out and back in and out and back in. Didn't notice any problems, so kind of incredibly boring and yeah, right. Actually, the most interesting thing when I went down to put the slides together for this is I realized that we actually got like a nice little performance win out of this as well. Like we kind of lopped off about 3 or 4 milliseconds from our P99 Redis. That's not why we did this, but we'll file that one away as more good reasons for you to kind of stay up to date on your gems, because sometimes people do nice things for you for free. Now, you might notice there's an asterisk next to the word upstreamed there. So we're not quite done yet getting these patches merged. Originally, I was actually like a bit sad that I wasn't going to be able to come up here and unfurl the proverbial mission accomplished banner. But I actually think it's good that I'm not quite done getting the patches merged. We actually ended up shipping a fork to production because I can actually stand up here and talk about something else, which is that working with upstream can be a lot slower, right? Like, if I go to a team at Zendesk and I tell them, your gem's broken, here's a patch, please fix. The same people are paying both of our salary, so there's levers to make them work at the appropriate level of velocity for us. But, open source maintainers don't owe us anything. We're not paying this guy. So if he wants to vanish for a few months and have a holiday, like, he's entitled to do that. And we've got to work around that schedule. So working upstream can be slower, and that's not a reason not to do it. It just means you kind of have to think about, well, can we be putting pre-release things into our production environment, ship a fork maybe, bake things in our production environment as we're sending them upstream as well. So, we've got to be respectful of people's, unpaid open source maintainership time. Like, there's a certain amount of like, hey, did you see this? That's probably acceptable, and probably too much is contributing to all that open source burnout stuff that people have talked about a lot. But yeah, I think we're almost there, and hopefully should be all merged soon. All right, so I actually have no idea how I'm doing for time, but no one's waving me off, so we're good. All right, what should you take away here? You've come here, you've listened to me yap for however many minutes it's been. What should you leave here with? I think, well, there's 2 sets of takeaways. There's some Redis-related takeaways and some more general-related takeaways. So on the Redis front, if you have a write-heavy workload, you may consider using Redis cluster. It could help you with scaling your writes out. You can do what we did, where you make the cluster have a single node and scale it out later. That way you don't have to kind of write a big check to AWS until you actually need it. And if you decide to go down this path, the redis-cluster-client gem is here for you. It supports pipelining and multi-key operations and will soon support transactions. And if you use this, please open issues if you find them, because I want to fix them, because they probably affect Zendesk as well. And that's kind of the magic of open source, really. So yes, use Redis cluster if it's appropriate for your use cases. See your doctor before making any treatment decisions. But more generally, on the open source ecosystem side of things, like, please keep your gems up to date. You don't know what you're missing out on by not doing this often. It's never the most important thing, but it is an important thing. Work with your upstreams. Don't be afraid to crack open gems, fix problems in them, debug your issues, as far down as you can, because you'll make the gem better for you as, for your app. You'll make it better for everyone else, and you'll make you a better engineer. And this is for everyone. Everyone's got something to contribute to open source. If you're using this gem, your experiences are valuable, even if you've nothing more to say than, I tried this and it worked, right? Like, that's good information. Yeah, so there are my socials. You can also find me this afternoon and throw tomatoes at me in person. And thank you for your time.